A charge-coupled device is a type of integrated circuit that combines analog and digital signal handling abilities. The CCD is made from a string of small capacitors. The first capacitor in the string stores a sample of the input voltage and then passes the sampled signal onto the next capacitor when clocked. With each successive control pulse, the input sample is passed along to the next capacitor in the string. In figure E6-3, what is the schematic symbol for a light-emitting diode? The answer is E. What is a liquid crystal display, an LCD? Answer B, a display using a crystalline liquid, which in conjunction with polarizing filters becomes opaque when voltage is applied. What is cathode ray tube CRT persistence? The answer is D, the length of time the image remains on the screen after the beam is turned off. Our next subject is digital electronics. In binary digital systems, you may have only two states, 0 or 1, an off or an on, or a mark or a space in communication systems. Digital systems are created using digital integrated circuits. In binary digital logic circuits, each combination of inputs results in a specific output or combination of outputs. The logical function of a particular type of gate may be described by listing all possible combinations of input and output values in a truth table. Here are some of the gates we'll be looking at. There are two types of gates that have only one input and one output, the non-inverting buffer and the inverter or NOT gate. The non-inverting buffer simply passes the same state, a 1 or a 0, from its input to its output. In an inverter or NOT circuit, a 1 at the input provides a 0 at the output, or vice versa. NOT implies inversion. The difference between these two gates is the small circle on the output of the inverter that means inversion. The AND operation results in a 1 on the output only when all inputs are a 1. The logical operator AND is usually denoted by a dot between the variables. The NAND operation results in a 0 on the output only when all inputs are a 1. The logical operator NAND is usually denoted by a dot between the variables and a bar over the combination. The OR operation results in a 1 on the output only if all the inputs are a 1. The logical operator OR is usually denoted by a plus sign between the variables. Note that the OR gate will have a 0 output only if all the inputs are a 0. The NOR operation results in a 0 on the output if any or all of the inputs are a 1. The logical operator NAND is usually denoted by a plus sign between the variables and a bar over the combination. Note that the NOR gate will have a 1 output only if all the inputs are a 0. It is common for many ICs to be connected in parallel on a data bus or address bus to share data or addressing information. In this configuration, only one IC output can control the signals of the bus at a time. All other IC outputs must stand by, by changing their outputs to a high impedance state without attempting to drive the bus to a high or low state. ICs with this ability are called tri-state logic, where their outputs can be high, low, or high impedance. A flip-flop is a logical element with two states, the set state, a 1, or a reset state, a 0. The state table shows that if both inputs are high at the same time, you can't tell what the output will be. There are normally two outputs that are complements of each other, designated Q and Q naught. If Q equals 1, Q naught equals 0, and vice versa. There are several types of flip-flops, including synchronous and asynchronous units. Synchronous flip-flops change output states only during prescribed times determined by the clock input. Asynchronous flip-flops can change output states whenever the input states change. A monostable multivibrator, or one-shot, has one stable state and an unstable state. When triggered, it switches to the unstable state and then returns to the stable state after a fixed period of time. A one-shot outputs a single pulse whenever triggered. An astable or free-running multivibrator continually switches between the two states. In other words, it outputs pulses continually. A counter, divider, or divide by n counter produces a pulse after a specified number of input pulses, in this case 10. Counters or divider circuits are used in ham radio as marker generators and frequency counters. TTL integrated circuits require a plus 5 volt power supply. They can work with 4.7 to 5.3 volts, but 5.0 volts is optimum. A Logic 1 output will be between 2.4 and 5 volts. A Logic 0 will be between 0 volts and 0.4 volts. Between 0.4 and 2.4 volts is no man's land. Complementary metal oxide semiconductor, or CMOS devices, can run off of 3 volts through 18 volts. As you can see, the Logic 1 and Logic 0 input levels are much higher than for TTL. This wider range gives CMOS circuits greater noise immunity than TTL, and their power consumption is far less. All CMOS circuits and devices require special handling to avoid static discharge.